Hello, my name is Joe Herrick. I'm presenting my assignment for the course Managing Machine Learning Projects. I chose a topic in the healthcare industry. Um, it's around nursing staffing forecast model based on patient volume and acuity to help nurses, basically unit managers, to take appropriate staffing decisions ahead of time. So I'm going to talk about, the opportunity overall. What is the CRISP DM business understanding? What would be the solution validation plan? What are the decisions that I will take in terms of machine learning system design? And what would be the potential risks in production? So for the opportunity evaluation, the main problem is that hospitals often struggle to have the right number of nurses in each unit. And uh, they have a number which is very important to nurses is the nurse-patient ratio. It's usually heavily impacted by this problem. So nurses are usually overwhelmed, especially in events like, the pandemic, COVID-19 pandemic. Um, when hospitals had a very little number of nurses compared to the number of patients needing care. And, predicting the number of patients who will be admitted to the hospital will help those unit managers to accurately staff their units, to have the right number of nurses to take care of the right number of patients. And at the same time, it's not only about the patient volume, but also about the patient acuity. What is the complexity of their cases? So it's really important to have a proper staffing based on those two numbers, the patient volume and patient acuity, to increase the nurse satisfaction. And at the same time, it's really important for the hospital to decrease the patient length of stay. So why is this opportunity attractive for a machine learning based solution? So first, there is a problem. I talked about the COVID-19. Overstaffing is putting an additional financial pressure on hospitals, and understaffing is pushing nurses to leave the healthcare industry. And hospital executives care a lot about this problem because the nursing force constitute around 60% of their total workforce. Therefore, it's a lot of financial pressure. And unit managers are losing nurses. Therefore, it's really hard to manage patients. Can ML help solve it? Absolutely, yes. So most hospitals are currently using information systems where they have historical patient data, so ML can use that vast amount of data to predict the number of patients to be admitted on a certain day. So what is the business understanding? So the target user is nurse manager or staffing coordinator. And the problem is to decide the number of nurses needed in a unit few days in advance. Because if the unit is overstaffed, the hospital lose money. If the unit is understaffed, nurses will be overwhelmed, and this become a reason for attrition. So the current state of the problem, unit managers use their instinct and previous day volume to staff shifts. How do we define success? So the expected impact is to improve the accuracy of staffing based on patient volume and acuity. The metrics, the outcome would be an increased accuracy of number of nurses per shift, and the output would be the MSE of aggregate predictions. The target is increased accuracy of number of nurses per shift to 90%, and the constraints prediction must be delivered 3 days in advance to allow unit managers to staff their units. Identify factors. So main factors, patient admissions to the inpatient units and emergency room, patient diagnosis to know the patient acuity, the weather data and season, because this will impact the number of patients admitted to the hospital. Events like musical events, social events, sports events that might lead to an increased patient admission. So the solution validation plan, the solution will be a web and mobile application that can be used by nurse managers and staff coordinators to check the patient volume. The tool will also recommend the number of nurses needed on a specific shift at a specific unit. So the ML tool will use a large amount of data, weather data, patient admission transfer and discharge data to predict the number of staff needed on a specific day. So this is a sample plan where we first, kick off the project, identify the scope and collect the data and collect the requirements from the customer, have it a limited scope, pick one nursing unit for the MVP, do workshops with stakeholders, identify the model outcome and output with the customer, start development and identify which model is the best, and then review the first prototype, collect user feedback, troubleshoot model performance if there is any, and then do a second review for the second prototype and do multiple iterations until we complete all units in the hospital and have a good model performance. So from a system design perspective, we will choose the cloud computations because the latency doesn't matter, relies on internet connectivity is acceptable, and the data that will be sent to the cloud, although it's patient data, we will anonymize it and send it to the cloud. We will have an offline and online learning. And how is that? So the offline learning will be for historical patient data and clinical data, which needs to be big enough to retrain the data. This should be done offline until we have enough data, which will impact the model outcome. And for the online learning, data like weather condition that needs to be, this can change a lot, and this should be ingested in real time to have a continued retraining of as new data arrives to update the model. And we're going to have online predictions. Users should have real-time predictions generated when needed to adjust the level of staffing in their unit on day-to-day basis. Last but not least, the potential risk in production can be three in this use case: the data drift. The number of admitted patients can be impacted by different events like weather conditions, like a pandemic, like the COVID-19 pandemic, and other local events. Another risk could be the concept drift. So people knows how to deal with COVID-19 nowadays because they went through it. So maybe less people might go to the hospital if they get COVID. Therefore, the model should be adapted accordingly. Although at the same time, patients might go to the hospital more often in winter than in summer. However, if people take flu shots, for example, less people will go to the emergency room. So we have to adapt the model accordingly as well. And the last risk I see is some data issues. Healthcare data can sometimes be messy. Many hospitals use information systems, but still data can still be messy. And we need to collect data from different sources in this use case, from weather companies, from hospitals, and from local events planner websites. Thank you very much.